Happy Monday morning, sixth graders. Today is May 11th. I'm going to go over your Unit 9 test today. I gave you a little bit extra time because last week was a short week, so I decided to send the video out today rather than on Friday. All right, so again, you don't have to turn in the Unit 9 test, but hopefully you have it done and you can go over it with me right now. The tree diagram below shows all the outfits Jay can choose to wear. An outfit has one color of shirt, one color of pants, and one color of shoes. So there's three different things. So what is the total number of possible outcomes with a white shirt? Okay, so we want to look at this and just check out the white shirts. Um, so all of these here are white shirts. All right, so that's what we were looking for. So we have 1, 2, 3, 4, 5, 6. There are 6 options with white shirts. Okay, because all these down here, all these options have red shirts, so none of these will work. So all these have white shirts. All right, so hopefully that makes sense there. All right, going on to the next one. It says a player. Let's see if I can get all of this on the screen. A player will spin each pointer one time while playing a game. So they're going to spin this one here, red, green, blue, or yellow, and those are all equal. And then they're going to spin this one's A, B, and C, and I can see that A is clearly bigger than B and C. It says list all the possible outcomes of one color and one letter. Okay, so we just got to write these out. All right, so we can have, I'm just going to do this with kind of a tree diagram here. We can have red, green, blue, and yellow. And then we can have A, B, and C, A, B, and C, A, B, and C, A, B, and C. So there are all of the options for one color and one letter. It says, explain why all the possible outcomes are not equally likely. Well, again, A has a bigger chance. So all of these A's are more likely to occur. Red, green, blue, and yellow are all equal, but red A, green A, blue A, and yellow A are all more likely to happen than a B or a C. Okay, so that's kind of the explanation we have there, because A is bigger. All right, moving on down. It says number 3, use the chart below to create a menu for a movie theater that results in 72 possible combinations of a popcorn, drink, and a snack. Decide how many popcorn sizes, drink sizes, and different snack sizes you will need to have 72 possible outcomes. Then come up with a menu showing your number of choices. You must have at least one option in each category. So you can't do like 72 popcorns and one drink size, and 72 times 1 would be 72. That won't work. So it says, here's a hint. Small and large popcorn, small and large drink, dots, Skittles, or Milk Duds. This will result with 12, because it would be 2 times 2 is 4, because there's 2 popcorns, 2 drinks, that's 4, times 3 is 12. So we need something times something times something equals 72. All right, so let's just go ahead and try something out here. If we do 3 popcorns and 4, let's say 4 drinks, that would be 12. All right, so 12 times 6 is 72. So we have 3 different, so that'll work. 3 times 4 times 6 is 72. So now we just got to come up with a different size. We could say small, medium, and large popcorn. We could say small, medium, large, and we can call that jumbo for drinks. And then snacks, we could say we have We have M&M's. Let's say we have Skittles. Let's say we have Reese's peanut butter cups. Let's say we have Snickers, Dots, and how about we do Mike and Ike's? That's kind of a movie favorite. All right, so 1, 2, 3, 4, 5, 6. Okay, so there we have three popcorns, 4 drinks, 6 different snacks, and that would equal 72 when we multiply them all together using the fundamental accounting principle. All right, so that's the end of that page. Let's move on to the next page. It says Susan has a box that contains 4 yellow, 8 green, 10 orange, and 3 red markers. Susan randomly selects a marker from the box. What's the probability that she does not select a yellow or orange marker? Okay, so we want the probability. We want the probability of not orange or yellow. All right, so I need a total. The total is going to be my denominator. So you got 4 plus 8 is 12, plus 10 is 22, plus 3 is 25. Okay, so 25 total. All right, now we don't want orange, we don't want yellow. So that's yellow. That's green. Green and red makes 11. And orange and yellow. So we have 11. 11 are not orange or yellow, and there's 25 total. So the probability is 11 out of 25. Number 2, it says draw a spinner where the probability of spinning blue is 1/4 and spinning red is 50%, and the remaining is yellow. All right. So we're going to go ahead and do 1/4 is blue and 50% is red. So I'm going to just draw a line down the middle. We're going to make this red. And then I'm going to cut this in half and we're going to make this blue. Okay, so this is 1/4, this is 1/2 or 50%, and the remaining is yellow. Okay, so your spinner should look something like that. Doesn't have to be exactly like that, but half of it should be red and 1/4 should be blue and 1/4 should be yellow. It says in decimal form, what is the probability of landing in the yellow section of the spinner? In decimal form, that would be 0.25. 1/4 is 25% or 0.25. So 0.25 because they ask for decimal form. All right, Ryan has 25 tiles. So there's 25 boxes there. The probability randomly chooses a green tile is 12%. Shade in the number of green tiles that Ryan could randomly choose. Okay, so there's a few different ways we could do this. One way is we could do 12 out of 100 because 12%. 12 is out of 100. And then 25 is our total. Okay, and we're looking for that number. So essentially, how do you get from 100 to 25? You're dividing by 4. So if we divide this by 4, we get 25. So if we divide 12 by 4, we get 3. So that tells us we should shade in 3. So I'm just going to go 1, 2, 3. All right, so that would be 12%. Shading in 3 of them. You could shade any of the 3. It doesn't really matter. So anyways, go ahead and take a look at that. Another thing you could do is you could take 12%, change it to a decimal, and multiply by 25, and that would also give you 3. So there's a couple different ways you could get that to show your work. It doesn't matter how you do it as long as you can come up with that answer. Okay, number 1, it says a single trial of an experiment consists of flipping a coin 3 times. Suppose you perform the experiment 100 times. About how many times would you expect to get heads, 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 or tails, tails, tails? All right, so the probability of getting heads when you flip a coin, so the probability of a heads is a half. So you would have a half times a half times a half. So the probability of getting the first heads is a half, second heads is a half, and third heads is a half. So the chances of you getting a heads, heads, heads is 1 out of 8. Of course, that's if you play it. That's if you play that game one time. You'd have a 1 out of 8 chance. So again, what I would do here is I would say, okay, we have 1 out of 8, and now we want to know how much out of 100. So it's a 1 out of 8 chance if you play it one time. You know, if you flip a coin 3 times, if you just do that one time, like that's one game. Flipping a coin 3 times is one game. Okay, so hopefully you remember maybe a little bit with proportions. We can cross multiply. We can cross multiply and divide. And you're going to end up with 12 and a half. 12 and a half times. So you should get a heads, 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 or a tails, 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 12 and a half times. You could round that up to, say, 13, because the 5 tells us to round up. So you'd expect that about 13 times out of 100 would be a good estimate. Okay, Jorge. Let's see if I can get the whole thing on the screen here. That's pretty good. Jorge, Greta, and Owen each performed 30 trials of an experiment using spinners shown below. Jorge's relative frequency for spinning red was 1/3. So I'm just going to go ahead and write that in there. Jorge's red was 1/3. All right. Greta's frequency for red was 2/5. And Owen's frequency for red was 1/10. So it says complete the table to show one possibility for the experimental results. Okay, so again, we could have different answers all over the place for this. Jorge, 1/3 of the time he had red, so you could literally, and they each did it 30 times, right? So Jorge could literally have, he could have 10 blue, 10 red, 10 yellow, and that would equal 30 total, right? So, and 10 red is 1/3, so that would work. 2/5. Okay, so 2/5 is what out of 30? Well, it's times 6 times 6, so that'd be 12. So 12 red for Greta. All right, so we could just, make this easy. We could say 8, 12, and 10, and that equals 30. Okay, you just have to have it equal to 30. And you got to make the red ones work for the data that we got. All right, and then Owen had 1/10 of the time. So if we say 1/10 equals what over 30? Again, that's times 3. So this is going to be a 3. Okay, so we just need it all to work out. So I mean, you could say 17, and now we have 20, and you could say 10 again. You know, it doesn't really matter. It just has to equal 30 in the end. So all three of these numbers have to equal 30, and the red has to fit. So the red has to be 10, 12, and 3. Okay, so all of our answers should be the same there. Red should be 10, 12, and 3. And your answers for blue and yellow don't really matter as long as it all adds up to 30. Okay, so you could have had 12 here and 8 here or something else. You know, that didn't necessarily matter. You could have had different answers there. All right. I think, yes, this is our last page, our last question. It says, in a survey, 20 students were asked their favorite breakfast food. The table below shows the results. Use the table to answer the following questions. So 10 people said cereal, 8 said muffin, and 2 said bagels. So that's 20 students altogether. What is the probability that a student likes bagels? Okay, bagels is 2 out of 20. So I'm just going to go ahead and write 2 out of 20. Okay, that would be 1 out of 10. So where it says fraction, I'm going to say 1 out of 10. Decimal would be 0.1. And then I move the decimal 2 spots to the right, and that would be 10%. So those are the 3 ways to write it. It says, about how many students out of 100 would you expect to like bagels? All right, so bagels, we just said, is 1 out of 10. So 1 out of 10. And now we're saying how many out of 100. So again, we multiply this by 10, multiply this by 10, and we would get 10. So about 10 students should like bagels if we asked this question to 100 people. Predict how many students out of 500 would like muffins. So again, we're going to do for muffins, we're going to do, all right, 8 out of 20. And I know you guys can't see that right there, so let me write it over here. Let's go 8 out of 20 equals what out of 500? Okay, so I know that if I multiply by 5, I get 100. So if I multiply by 25, I get 500, right? So 20 times 25. Okay, so 20 times 25 is 500. 20 times 25, because 20 times 5 is 100, and times 5 more is 500, so 5 times 5 is 25. 20 times 25 is 500, so if we do 8 times 25, or in other words, 8 quarters, right, that would equal 200. So again, we're using muffins here. Muffins is 8. All right, 8 out of 20, 8 out of 20. You could divide that, right? There's lots of ways to do these problems. You could say 8 out of 20 is 0.4, and you could take that times 500, and that would also give you 200 people. So there's a lot of ways to do this. You can, using this way, setting up with ratios and fractions, that's called a proportion. You could take the 8 out of 20 and change it to a decimal with division, and then just multiply by the total, 500, and that gives you 200. So again, there's a lot of ways to do these problems, but ultimately about 200 people would like muffins according to our survey data. All right. So again, you do not have to turn in the Unit 9 test. This is just meant for you to be able to go over it so you could reflect on it and see kind of how you did. Um, if you have any questions to that, feel free to ask. Have a good day. Good day.